IOE 413, Mathematical Preliminaries Study Guide. So this problem is about basic feasible solutions. Consider the system AX equals B, X non-negative. We're going to consider a specific X, A, and B and see whether that vector X is in fact a basic feasible solution. So the system is going to be defined by A is this long matrix here of -1, 10, 2, 1, 1, 0, 5.3, and 1.2, 2, 6, 0, 2, and -1.2 and -1.7. B would be simply 3, 2. And X, right over here, is this big, long column vector with 7 components. 0, 0, 3, 0, 0, 1, 0. And the question is X A, B, F, S? That's the question for this problem. Well, let's begin by looking to see whether, in fact, it is a solution. And what does a solution mean? Is X a solution? So let's write down the system AX equals B. If X satisfies this, then it is, in fact, a solution. That's the definition of a vector being a solution. So we have, again, -1, 10, 2, 1, 1, 0, 5.3, 1.2, 2, 6, 0, 2, -1.2, -1.7, oops, -1.7 there. Then we have our X vector, it's a big long one, 0, 0, 3, 0, 0, 1, 0. To be a solution, it just has to satisfy this, equals 3, 2. And if you look at this, you take the inner product of the first row and X, and what you see is, in fact, that's 0, 0. So that's 0, 0 times those. Oh, look at this. You pick up 1 times 3. There's 2 more zeros. And then there's 0 times 1. So 0 times 1 is 0. And then 1.2 times 0 is 0. So you just pick up 1 times 3 is equal to, look at that, 3. Now let's look at the second row. Here you get 1, 2, 3. The first 2 elements are times 0. So you pick up nothing there. And then you have 0 times 3. You pick up nothing. Then you 1.2 times 0. 6 times 0. 2 times 1. Hey, look, 2 times 1. And then -1.7 times 0. That's 0. So the only thing you pick up here that's non-zero is 2 times 1 is equal to 2. So check. X is a solution. X is a solution. We are 1/3 of the way there. X is a solution. Now we have to get at, is X a feasible solution? So to get at, is X a feasible solution? A feasible solution is just one that is a solution and is in fact feasible. This is what feasibility means. X is non-negative. Let's look at our vector X, which was 0, 0, 3, 0, 0, 1, 0. In fact, all of those components are non-negative. So in fact, first one, yes, 0 is greater than or equal to 0. 0 is greater than or equal to 0. 3 is greater than or equal to 0. 0 is greater than or equal to 0. 0 is greater than or equal to 0. 1 is in fact greater than or equal to 0. And 0 is greater than or equal to 0. So x is greater than or equal to 0. Check. X is feasible. We are now 2/3 of the way to being done with a really poorly drawn box there, but you can still read it. X is feasible. So the next thing we have to do is look, is X a basic solution? Is it a basic feasible solution? So to get at that, we have to go back and write out our A matrix again. -1, 10, 2, 1, 1, 0, 5.3, and 1.2, 2, 6, 0, 2, -1.2, -1.7. Let's write, instead of writing down x, let's write down x transpose so we can line this up just a little bit better. We have 0, 0, 3, 0, 0, 1, 0. And you'll recall from the lecture notes, to determine if a solution corresponds to a basic feasible solution, the basic part of it, you look at the elements of your vector that are non-zero. So we have a 3, we have a 1. You ignore all the other ones that are 0. What you do is you look at the columns of A that correspond to the non-zero elements of X. I'm putting boxes around them. And then you consider the set of these two vectors, 1, 0, and 0, 2, and ask, are these vectors linearly independent? Well, you'll recall from earlier problems, we can check that by computing the determinant of a 2x2 matrix that has these vectors, the columns of A that correspond to the non-zero entries of X, as the columns of this 2x2 matrix. 1, 0, 0, 2. This determinant is trivial. It is 1 times 2 minus 0 times 0 is equal to 2. It is not equal to 0. Therefore, these two vectors are linearly independent. So we have the elements, the columns of A that correspond to the non-zero elements of X are linearly independent. X is feasible, and X is a solution. Therefore, we've satisfied the 3 criteria for X to be a basic feasible solution.